Hey guys, this is Group 13, our final project presentation. This is our Dark Souls 3 weapons project. My name is Andrew Lamb.
I'm Mohamad Moumneh.
And I'm Logan Hamilton.
Yeah, and Christopher Parker couldn't be here today, but he did contribute to the project. So a little overview about the data, a little bit about the data. We got our data from Kaggle. The data houses statistics on all the Dark Souls 3 weapons. Some features that they include are weapon category, damage, range, weight, stat bonuses, and other stuff. The data spans 287 unique rows and 17 columns. A little overview about the presentation. First, we're going to go into the problem, questions, and overall goal. Then we're going to go into pre-processing and modeling. Then we're going to go over to our results and our model evaluation, stuff like that. And we're going to close off the presentation with the impact of our project. So first, I'm going to talk a little bit about our problem. So the problem that we're trying to solve is trying to cluster the weapons into categories based off of their damage. Now, each weapon does have a base damage statistics in our table. However, we want to be a little more in depth. We want to include the size and weight of the weapon as well as other stuff that we include in our cluster. Going into our questions, we have three main questions we want to answer. First one we want to answer is what are the highest damaging weapons and what are the lowest damaging weapons? Second one I want to go over is how do each weapon scale? So which weapons have the worst scaling and which weapons have the best scaling? And the last one is how does weight affect the weapon's damage output? So we have two main goals that we want to tackle. So the first one is simplify the data so we can define the best weapons to use for builds through most Dark Souls 3 playthroughs. So Dark Souls 3 is a very hard game where each weapon, each statistic in your build matter a lot, and it can completely change the way you play through the game or how tough the game is. So we feel that this data is very valuable to people who've been playing Dark Souls 3 for a while, or people who are even just starting to get into it. And our last goal is to remove any weak weapons that don't seem viable from the damage standpoint. So like any weapons that are irrelevant to gameplay, like weak weapons, we're just going to completely get rid of those.
Okay, this is the pre-processing part of the project. Now, for pre-processing, the first thing we did was pretty standard checking for nulls in the dataset. This revealed a lot of null values in the dataset, and this is because certain weapons don't have stats, certain stats. For example, melee weapons don't have a range stats. So getting rid of these nulls was pretty easy because the columns sell price, spell buff, and range really had nothing to do with our model. So we could safely drop these columns and continue with the project. And the other part of our pre-processing including us scaling the attributes like damage and weight using the standard scaler. Pictures can be seen to the right. And this is done to create a more consistent cluster. Moving on to clustering. As a reminder, clustering is an unsupervised machine learning technique with the main goal of creating groups with similar traits and then assigning those traits into clusters. We're using k-means clustering, which divides the data into k non-overlapping clusters. Clustering is a powerful tool because it can be used to reveal hidden patterns in data. Okay, moving on to our model, you can see we have three different clusters here based on base damage output, weight, and damage category. You can see the blue clusters have a damage stat of less than or equal to 80, and then the green clusters are between 80 and 120 damage, and the red clusters are weapons that are above 120 damage. And you see the sort of trend here where higher damaging weapons also have a higher weight.
All right, moving on to the results and evaluations and conclusions. So as we could see, as we kind of already discussed, there's three distinct clusters, and there's a pattern where the higher the damage weapons also tend to weigh more. The heaviest low damage weapon only has a weight of about 10, while there are many, many weapons over 20 that weigh more than 10. So there are certain advantages and disadvantages that come to a higher damage. With a higher weight is not a good thing. Higher damage is obviously good. So like if you have a higher damage weapon with a higher weight, you'll do more damage, obviously, but you will also be a lot slower and could attack slower and move slower and dodge slower. Okay. On to the conclusions. We decided that we could further improve our model by adding more features to the clustering model in order to group weapons based together on other attributes as well. Clustering weapons in this way does not tell the full story of how a weapon functions, as there are additional factors to consider, such as swing speed or attack speed. We also concluded that damage output is not the same as DPS, or damage per second. On to the impact. So this is just a game, but it still can have impacts on the community or even for the developers. So the first impact we found was that it could help developers balance weapons. If they could see that there's a weapon that is severely outlying, like doing a lot of damage while being low weight, they can balance that better so there's not a completely overpowered weapon. It could also act as a guide for new players. They can find a weapon that suits their playstyle while also just being a good weapon. And similar to that, it can help optimize gameplay strategies, as you could find a weapon that does the most damage while also being the lowest amount of weight for whatever build in the game you want to be. All right, thank you for watching our presentation.